Hello, in this video, we will be learning how to solve multi-step word problems in algebra. Now, let's get started. Our first question is, Elena has 3 times as many t-shirts as Mary. Together, they have 20 t-shirts. How many does each have? So, our first step to solving this problem, and any word problem in general, is to define our variables clearly. So here we care about how many t-shirts Elena has and how many t-shirts Mary has. Since we don't know the value of either of them, let's set some variables for them. So let's start with E equals Elena's t-shirts and M can be Mary's t-shirts. For variables, you can really choose any letter. You could also do like X and Y if you like. But normally I like to name it something that it's easy for me to remember. Like E for Elena and M for Mary makes sense to me. So let's start with Elena having 3 times as many t-shirts as Mary. That means our first equation is going to be E equals 3 times M, because 3 times as many is going to represent it as 3 times M. Our next information is that they together have 20 t-shirts. So we know that E plus M is going to be equal to 20. The number of t-shirts Elena has plus the number of t-shirts that Mary has is going to equal 20. In this case, we know that E is equal to 3M. So let's substitute that in. So we get 3M plus M equals 20. 3M plus M equals 4M, which equals 20. If we divide both sides by 4, we get that M equals 5. So Mary has 5 t-shirts. Now we solve for how many t-shirts that Elena has. Since we know it's 3 times the number of Mary, we know that E is going to equal 3 times 5, which is 15. So Elena has 15 t-shirts, while Mary has 5 t-shirts. Now let's do this problem. The sum of 3 consecutive even integers is 48. What are the integers? So here we know that we're looking for 3 integers. And just by the fact that we have 3, we know that one of them is going to be the smallest, one of them is going to be the middle, and one of them is going to be the largest. Now, what do we know about these integers? We know that they're consecutive and even integers. So let's say the smallest is x. So the middle value needs to be the next consecutive even integer, which is going to be x plus 2. And if the middle is x plus 2, then the largest has to be x plus 4. And we know that the sum of all of these 3 is going to be 48. So now we can add up x, x plus 2, and x plus 4. Let's do that now. X plus 2 plus x plus 4 is equal to 48. So we have x, we have 3x, plus 2 plus 4 is plus 6, equal to 48. So we have 3x is equal to 48 minus 6, which is 42. And then we divide by 3 to get x equals 14. So if x is 14, then we know that the smallest one is 14, the middle one's going to be 16, and the last one's going to be 18. So we know the answer is 14, 16, and 18. For this question, we are given that the length of a rectangle is 5 more than 2 times the width. The perimeter is 46 units, and we're looking for the dimensions. So we're looking for the length and the width. So first, let's start off by drawing this rectangle. This is our rectangle, and we're gonna make L be equal to length and W be equal to width as our two variables. So we have L here and W here. And we know that the perimeter is gonna be 2 times length plus width, because the perimeter is length plus width plus width. So now, what other information do we know that could help us out? We know that the length of a rectangle is 5 more than 2 times the width. That means this length here can be written as 5 more than 2 times the width. So now that we know this, we can plug this in to find the answer. So 2 times L plus W is equal to 46. 2 times length is going to be 5 plus 2W plus W equals 46. We can divide both sides by 2 because we're multiplying this entire thing by 2. So we divide by 2, we get 5 plus 2W plus W is equal to 46 divided by 2, which is 23. Now let's simplify both sides. We get 3W plus 5 equals 23, which means 3W is equal to 18. Now we divide both sides by 3, and we get that W equals 6. Now that we have the width being 6, we want to find the length now. So length is equal to 5 plus 2W, which is equal to 5 plus 2 times 6, which is equal to 5 plus 12, which is equal to 17. So we know that the length is 17 units, and the width is 6 units. For this question, we have one number is 7 more than 3 times another number. Their sum is 43. Find both numbers. So here we have two unknown numbers, and it can sometimes get a little bit confusing which number you're referring to when you solve for the equation. So why don't we make two variables, and we can have x be the small number and y be the large number. So in this case, we have one number is 7 more than 3 times another number. So this first number here is going to be our larger number, and this one's going to be our smaller number. So we can have y is equal to 7 more, so we're adding 7, plus 3 times another number, so 3 times the smaller number, 3x. In this case, we also have that their sum is 43, so we know that x plus y, which is the sum of two numbers, is 43. Now we can plug in y for 7 plus 3x and solve for x. So let's do that now. X plus 7 plus 3x is equal to 43. So we have x plus 3x, which is 4x. We have a 7 here, so plus 7 is equal to 43. We can subtract both sides by 7 and get 4x equals 36. Once we divide both sides by 4, we get that x equals 9. Okay, now that we have our smaller number, let's find our larger one by plugging 9 in for x right here. So y equals 7 plus 3 times 9, which is giving us 7 plus 27, which is 34. So the two numbers are 9 and 34. This question states, you have some $5 bills and some $10 bills. There are 16 bills total worth $125. How many of each bill are there? So first, let's start with defining our variables. So we can have f equal number of $5 bills, and we can have t equal the number of $10 bills. So first, we know that we have 16 bills total, so we know f plus t should equal 16. And we know that total, they're worth $125. So that one means that we can do 5 times F, because with every increase of a $5 bill, you have $5 more, plus 10 times T, because every time you have a $10 bill, you add $10 in value, which equals 125. Now for this one, there's a few ways you can solve it. You can either solve by substitution or elimination. In this case, I'm going to use elimination. But first, I'm gonna multiply the top by 5. Okay, so if I multiply the top by 5, I can get 5F plus 5T is equal to 16 times 5, which is 80. So on the bottom, we'll have 5F plus 10T equals 125, which means if I subtract both of these equations from each other, I can get 5T minus 10T, which is negative 5T, is equal to 80 minus 125, which is negative 45. So we know that T is 9. So there's 9 $10 bills. Now we know that F plus T equals 16. So F plus 9 equals 16. So we know that F equals 7. So we know we have 7 $5 bills and 9 $10 bills. For this question, we have, after a 20% increase, the price of a jacket is $72. What was the original price? So for this one, after a 20% increase, the price of a jacket is $72. So we know that the original price was lower. The original price should be, let's just write P as original price, our variable. So we have the original price, plus we have a 20% increase that we can write as 0.2 times P is equal to 72. And now we have one equation that we can solve. So P plus 0.2P is going to be 1.2 times P, which is equal to 72. If we divide both sides by 1.2, we get P equals 60. So the original price is $60. So for this question, we have kind of an age time shift question. It's a pretty common Algebra 1 question, but it can get a little bit confusing. So let's break it down. The problem is, a father is 4 times as old as his son. 6 years ago, he was 6 times as old as his son. How old are they now? So it can get a little bit confusing because we're dealing with the present and the past, but we can break it down so it becomes simple. So first, let's start with defining our variables. We can make F equal to the father's age. And this is going to be the father's present age. And S is going to be the son's age, also their present age. So first, let's start with the present. What do we know? Right now, the father is 4 times as old as his son. That means F is equal to 4 times S. Now, we also have information about the past. 6 years ago, he was 6 times as old as his son. So if we subtract 6 off the father's age, he was 6 times as old. So 6 times S minus 6. What's important here is that you make sure that when you're subtracting 6 off the father, you also subtract 6 off the son. Now we should be able to solve. Let's simplify this first. F minus 6 equals 6S minus 36. And in this case, we know that F is equal to 4S, so we can plug that in. So we have 4S minus 6 equals 6S minus 36. We're going to move the 4S to the right over here so we have it positive. We can have negative 6 equals 2S minus 36. We're going to add 36 to both sides, and we get 30 equals 2s. So we know that s is equal to 15. Now we can find the father's age because he's 4 times the son's age. So f is equal to 4 times 15. So we know he's 60. So the father is 60 years old. The son is 15. And that's the end of today's video. Thank you so much for watching.